because let's go ahead and talk about the different things that we can do with arrays or certain restrictions first. The first restriction about arrays is all elements inside an array, they must have the same type. It is roughly equivalent to you have a box, but inside the box you can only have all coffee mugs, you can only have all wine glasses and so on. You cannot have coffee mugs and wine glasses mixed together. In the sense of programming, it means all elements in an array, they must all be integers, they must all be real numbers, they must all be booleans, and so on. You cannot have a mixture and say, okay, some of these are booleans, some of these are integers, and some are real numbers. You cannot have a mixture of different types. Each element has an index. Basically, it is identified by a number. In this example, we have 0, 1, 2, 3 to identify each individual container inside that box. The index of the first element is always 0. Okay, this is somewhat counterintuitive because as people, we always count from 1. Okay, we rarely count from 0. But when you're dealing with programs, in almost every modern programming language, you always count from 0 when you are indexing, when you are accessing elements in an array. Now, this is something that you just have to remember, because I cannot explain the reason why we count from 0 in this class. We have to wait until the assembly programming class to make it kind of clear why we have to count from 0. The indexes is basically the plural of index, or one way to spell the plural of index. Indexes of elements must be contiguous. It has to go from 1 to 2, 2 to 3, and so on. You cannot skip numbers. Okay. Any questions so far? Any questions? If A is an array, bar A bar indicates the number of elements in A. In other words, the typical notation of absolute number does not mean absolute numbers in this class. In this class, the same notation means the number of elements in a particular array. You can kind of think of the bar A bar as the usual symbol of measuring the width of something. Okay, so if you think of it that way, it's kind of telling you that it is measuring the size or the number of elements inside an array. Okay. Are there any questions about the bar A bar symbol? Yep, go ahead.
So, if we're writing the index and inside the square brackets is how many are in?
No, we are not talking about square brackets yet. This is bar A bar. It's the vertical bar on the keyboard.
Oh, okay.
The vertical bar on the keyboard is on top of the backslash key, which is usually above the enter key on the keyboard.
Okay, that's what I was confused.
Okay. Mm-hmm. All right. So the next item is kind of, it follows the previous two items. The last element in an array A has an index of bar A bar minus 1. It's a combination of the previous two statements. The first statement states that elements have to go from 0 and they must be contiguous. The second statement states that bar A bar indicates the number of elements in A. So that means the last element in an array, it must have an index of bar A bar minus 1. It is not bar A bar because we count from 0. Are there any questions so far about properties and restrictions of arrays? Yep, go ahead.
Bar A bar is going to be some sort of value that's only indicated by the amount of whatever is in that array.
Yeah, the number of items or number of elements in the array.
And it wouldn't be given.
That has to be given to you. If I want you to trace an algorithm that has to do with an array, I have to tell you ahead of time what is the number of elements in that array.
Okay.
Yep. Cannot be.
Just be indicated as bar A bar equals this.
Yeah, I have to tell you. I can tell you using the bar A bar equals symbol. I can give you a trace that starts with a certain number of elements in an array. We'll get to that part a little bit later. Or I can just say the number of elements in A is 4, 5, whatever. Okay. Yep. Go ahead, Fabian.
So 0 is still an item of the array?
The first item in the array has a number, 0. It is indexed, it is identified by the number 0. It doesn't mean the value is 0, it simply has a label of 0. Like in this case, we have, this array has 4 elements, right? We have 4 containers inside this array. So that makes bar A bar, in this case, equal to 4. But the last element has a number of 3 because we count from 0. Yep, go ahead.
What is meant by all elements in an array have the same type?
That means you cannot mix types inside an array. You cannot have integers for the first one, for the first 5, followed by a Boolean, and then followed by 3 real numbers, and so on and so forth. If you have integers, they all must be integers inside an array. Yep, go ahead. Just one more question back there.
You answered it already.
Okay. So are there any questions so far about arrays? Okay, we're just kind of ignoring the last one, which is the most important part of using an array. No questions? Okay. So now let's go ahead and talk about the last one. The last one talks about the index operator. The square bracket thing is usually called the indexing operator. And it is really useful because it can be used to combine the number with the name of the box so that now I can say, specifically which container am I talking about. If I say A and then square bracket 2, it means I want to access box A. But which item do I want to access inside box A? Well, whatever item that has an index of 2. Okay, so A square bracket 2 is basically designating a specific element inside a box with the name A. Are there any questions about this? But this is just, go ahead.
Okay, so an indexing operator is like the name of the container. So if I want, like you were talking about A2, I'm talking about in box A, the third element, right?
Yes, when we count by first, second, and third, then we call it the third element.
Okay, so A2 is the third element, and whatever we're telling it to do, make it equal to 0, right?
Then you can say A square bracket 2, left arrow 0.
And it will only make the third element 0.
Exactly. That is correct. Very good. Good question. Yep, go ahead.
Since the box is named A, can you have more boxes?
You can have any number of boxes. The only restriction is no 2 boxes must have the same name. No 2 variables in general can have the same name. But you can have as many boxes as you want. You can have 1 box of Booleans, 1 box of integers, and another box for real numbers.
Can you have 2 real number boxes named?
Yeah, absolutely. Yep. You can have any number of boxes, and they can be anything. They can have different types and different sizes. They just cannot have the same name. Okay. Are there any? Yep. Go ahead.
Can you have 2 boxes of the same type? Like let's say
Yeah.
these are integers. So
Yeah.
then I have box A of integers and box B of integers?
Yes, absolutely. Yep. The only restriction is you cannot have 2 boxes of the same name, and items within the same box must be of the same type.
Okay.
So are we okay so far with the notations? Now there is one thing that I have not made very clear in my notes or in the discussion so far. What I have not made clear is whatever you put inside a square bracket, this thing here, it does not have to be a constant. It doesn't have to be 0, 1, 2, 3, 4, and so on. It does not even have to be a variable name. It doesn't have to be I, J, K, or X, Y. It can be anything. Anything that evaluates to an integer value can be put inside the square brackets. Now that is very powerful, okay? Because what happens now is instead of using a single constant, you can replace the single constant with some complicated expression here. the same line of code, depending on what the expression evaluates to, can now be used to address a different element in the array. You cannot change the box. The box is implied by a name, and the name cannot change, because your program, on this particular line is always using the same name. But now you have control over which item inside that box I want to access, because this expression does not have to be a constant. Okay?
That makes no sense. How can it not be a constant but identify an element?
Well, let's go ahead and look at the first example. We'll look at the first algorithm to find out what it can do and why it makes sense to be able to do that. It is actually on the next slide in the notes, but I will just go ahead and trace it anyway with a spreadsheet. Let's see, this one already has a full trace in the notes. In other words, if you don't copy anything from this class, it's already in the notes. But I will go ahead and interactively trace it, because I think this way I can slow down, and then you guys can ask questions more easily. This is the one that I used on Friday. I will start with. I'll just use a new one so that we don't get to see the final answer right away. In this algorithm, I would use a variable I and have it initialized to 0. In this case, you have to remember I as a variable is no more special than any other variables that we have talked about. I is just a variable that so happens to be initialized to 0 in this case. We have a loop. The loop says while I is less than bar a bar, do the following, which kind of implies that inside the loop body itself, I will have to change I. Does it make sense? Because if the condition of a loop involves I and bar a bar, then one of those two has to change in order to make the loop exit at some point. Bar a bar cannot change for the most part. Okay, there are programming languages where you can change the size of an array dynamically, but since most of you are moving on to a C class, you basically have to make the assumption that the size of an array is static. Okay, once it is 5, it is always 5. So inside here, the first thing I do is to say a bracket I gets 0, and the next thing I do is to increment I gets I plus 1. And while. This example is already in the notes. I just want to trace it in the class so that way it's more interactive. Okay. Are there any questions about the algorithm itself? Let's just go take a look at the algorithm itself line by line before we trace it. Any questions about the first line? Fairly standard stuff? No, nothing special. The second line is a little bit special because you do have to know what is bar a bar before you can evaluate whether I is less than bar a bar or not. But as I said, I always have to tell you the size of an array if I ask you to trace anything involving arrays. So bar a bar is always either implied or given explicitly. The third line is a bracket I gets 0. Now, that is a little bit more mysterious because we seem to have two variables on the left-hand side. Remember, the assignment statement should only have one variable on the left-hand side, but this time we seem to have two variables on the left-hand side. We have the array A, and then we have the variable I. So when we get to that line, in the trace, I'll explain in more detail exactly what that line is doing. Line 4 should not be a big surprise. All we are doing is adding 1 to the variable I, which is something that we have done many, many times. Are there any questions?
Yeah.
Yep, go ahead.
In line 3, does that mean that we're making it the first one in the array?
It depends on what